shall we get started with the recording and get moving? All right. All right, so we are recording now. So for those of you who are or aren't comfortable with being on video, we're recording now. And I want to welcome you all so much to the August meeting of the Salt Lake City R user group. We are so glad that you are here, whether you are you are local here in Utah or Salt Lake City here, or you are from further away. We are really glad that you are here. My name is Julia Silge, and some of our other organizers here are Andrew Red, and actually Mark, who is presenting today, is one of our other organizers, and we are really glad to welcome you. Before we get started, I imagine that most of you found us through our meetup site, but I will drop a link here in a minute to that so that you can be sure to keep up with us and what we're doing. And before we get started, I will just draw your attention to the fact that this is a friendly and professional space, and we expect everyone here to, even though we're online, to interact with each other with professionalism. And we use the R Consortium's Code of Conduct here. I'll link to that here. Mark is going to be concentrating on presenting, and Andrew and I are here and are available to do any moderation that may be required. We don't expect anything untoward to happen, but we want to make clear that that is our goals and values for this space. So this is our August meeting. We do have our September meeting lined up, which you can find. It will be an online meeting. You know, this is what we're doing for the time being. So our September meeting is going to be from a speaker who is not local. His name is Emil Wiefelt, and I'm actually writing a book with Emil about supervised machine learning for techs, and the topic of his talk is focused around defaults for modeling choices, with kind of a case study of looking at like stop word lexicons for text modeling. So I think that'll be a great talk, so you can look at that. Today, our speaker is, I'm really excited about this topic today, because it is so important for how so many of us work now, so important for really increasing the impact of what it is that we do. So Mark Nielsen is our speaker today, and Mark is a data scientist at Intermountain Healthcare, which, for those of you who are not from around here, Intermountain Healthcare is one of the biggest healthcare systems here in the region where we work. And Mark leads the development of machine learning engineering pipelines for building machine learning for patient and caregiver workflows. And Mark, as you can see here on the slide, Mark is going to be talking about using Docker for productionizing R code. So Mark, thank you so much for your work in preparing this and for talking to us.
Hey, thank you. All right, we ready to go? Okay. So thank you so much for that introduction, Julia. You know, to give you a little bit more background and on some of my experience, I graduated with master's degree in statistics about 10 years ago. And since then, you know, I worked for 5 years at a credit card bank as a credit risk and marketing analyst. And it was a small bank, so we wore many hats, and that's where my first exposure to Docker came from. One of my coworkers was definitely much more of an expert with Docker than I was, and I really was able to see the value it provided. And honestly, right now, working at Intermountain Healthcare, of course, has been for our team crazy busy, and we've gone through a ton of growth the past few months since COVID started in supporting our leadership in trying to understand the growth of COVID-19. And so, you know, we've got a small team and there's a lot of work to do. So Docker has really been a great friend for us the past few months, and we've really definitely matured and headed down a great path. And you know, on a personal side, you know, when I have the time, I like to occasionally go out mountain biking, but honestly, I really love playing around with 3D printer that we have, and trying to put some robotics together. And interestingly, the part that I always get stuck on, maybe it's because I do it at work all day, is coding. You know, creating those 3D prints are awesome and fun, but I'm working on a Rubik's Cube solving robot, which is pretty fun. I'm almost there. Just another year and a half or so. No, I'm just teasing. It'll be some time, but it's a fun hobby. Let me pull up the slides here. Just give you a quick introduction to Intermountain Healthcare. And I wasn't able to update these. This is from a few years back, but Intermountain has 22 hospitals. I think that's actually 23 now and counting, because we've recently acquired, I believe it's Nevada Partners Health. Oh, okay, I don't remember the name exactly, but you know, we've got a lot of clinics and what we call Instacare, which is kind of like urgent care clinics around the state of Utah, and also some in Idaho, and now some in Nevada. We have a large physician medical group, right? And many of those physicians are employed by Intermountain Healthcare, and we also have about 800,000 members in our healthcare plan at Select Health. So pretty big organization in Utah. I think our market share for healthcare is probably around 50% here in the state of Utah. And you know, for those that have a plan with Select Health, that's maybe about a quarter of the population here in Utah. So it's pretty big. So we have lots and lots and lots of data, and Intermountain Healthcare has always had a history of having data collection for many years, and so we definitely do have lots of data, and it's a pleasure to work, and there's lots of fun, exciting projects to work on because of that. So so I'm going to put an email up here, and this email is I want to use kind of as a motivation. This was a few years back when I first started at Intermountain Healthcare. I was handed off a project called our risk pre-screen risk model, which was pretty funny because I just came from a credit card bank, and we also had a pre-screen risk model, and they were named exactly the same. And I'm like, man, what a coincidence. But essentially what this model is for is we want to try and identify patients that are highest at risk, and for future medical expense, right? And sometimes the hard thing about using future medical expense is that you don't necessarily get the patients that actually need the care, but it's pretty good at trying to identify patients that that have a lot of healthcare need. And so what I did when I first started was really kind of consolidate a lot of the scripts. This was all done manually. We'd create a CSV and then send that to whoever was asking for it, right? And so the first step in this process was really to consolidate those scripts, automate it, get it set up into an ETL process with our data engineering team, and we were doing pretty good. And then this is where we were presented with a problem. We've got our data engineering team helping us automate this. I send them some new changes to the script, and they are definitely an incredible team to work with, and are wanting to figure out, like, okay, I've got some errors, and they just take the time, plug through, figure it out, and then maybe a week or two later I get this email like, hey, we're still getting an error on the IRPM or our pre-screen model, and made some adjustments. These are, okay, we've added some packages, and I don't know if you say Magritter or Magic Writer, dplyr, tidyr, to make sure we could get the pipe functionalities and other functions. We're missing the Intermountain library. So this was an interesting one. I had to start thinking like, okay, in this environment, how do I easily make some of our custom built internal packages available for them pretty readily? There's always been some of a gap, and it's closing. There's always been a gap between our data science team and our data engineering team, and because the data scientists are getting better at Linux administration and those kind of things, database administration, but the data engineers are truly the experts. And then on the flip side, data scientists are really good with R and Python code, and administering R and Python. And so talking about these first two bullet points, one of the things that I was shocked to find out, as a developer, I'm like, oh, I'm using a bunch of the tidyverse libraries. I'm just going to include tidyverse in my production code. And little did I know that our data engineers had no internet access on these machines, right? Because of data security. And they were building every single package from source files. And I was like, oh my goodness, no way. Oh, I felt so bad that I included tidyverse out of all the packages. And because, he went through kind of this iterative process. Okay, install tidyverse. This package isn't installed. Okay, install this other package. Oh, this package isn't installed. And so that really is where kind of the idea was born of, hey, we really need to make this a lot simpler for our data engineers. They are great at what they do, and we really, I don't want to waste his time really by making him rebuild everything. And some of the other things too here, that he highlighted, I think there's a little bit of a typo in the email, but he said there was a NI function here, percent NI percent. I changed it to percent, and it should say IN, right, in. And we actually implemented the percent NI, which means not in, function into our Intermountain library. And having him kind of reverse that actually negated what it was supposed to do. So that's something we had to work out. And then the last of all, he sent me screenshots saying like, I don't know what error, I don't know how to solve this error. I've tried and tried, I can't figure it out. And when he sent this to me, I'm like, oh, I'm 90% sure I know exactly what's happening with this error. I was so familiar with the code that I said, oh, okay, I'm sorry. I need to make some tweaks in the code that I sent you, and I'll resend you the R code. And so, so the idea of Docker was born, and I want to talk a little bit about why. On the right-hand side here is just a very basic image that I pulled from docker.com that kind of explains maybe a little bit of the difference between Docker and a virtual machine. Virtual machines, you typically have that host operating system within every application, right? But Docker can be built on top of the host operating system, but then still allow a lot of different applications to be built on top of that. But these are some of the reasons why we really wanted to use Docker, right? As a data scientist, I wanted to create an environment that I know and had complete confidence that if I can get it to run, I know anybody can get it to run, right? We wanted something that was super easy to push from, dev and test to production. We didn't want to create additional work for our data engineers or DevOps group to recreate what we've already created. One of the benefits that we've kind of gone back and forth a little bit with is, as you create these Docker containers or these images, you have sudo. So you have complete control over how you're going to set it up, right? Which for us data scientists, we're like, oh yeah, we can install any package we want. We can do whatever, and that's good. And cybersecurity. I'm sorry if there's any Intermountain cybersecurity people on the call right now. It's probably making them really nervous, but there's definitely some additional governance there. But as a data scientist, I really love that piece. One of the things that I also realized as I was creating my Docker files to generate these apps is, hey, this is a set of instructions on how I set up my environment. I don't know how many times I've been kind of a quasi Linux admin for our data science team for the virtual machines we're working on, and I installed some of the spatial packages somehow on Red Hat, and someone's like, oh, I need a bigger machine, can you install it on this other machine? And I'm like, I don't know what to do. I have to pull up my notes, and hopefully it's still in the bash history, and oh man, it's kind of a mess. But some packages are extra work to install. But I really liked having those generated instructions that I know how step by step I set up the environment to be able to install that, configure it. It really, minimized some of the Linux administration. And although we won't talk about it today, it really makes it your application scalable, because now that you have it in a Docker container, you can use other tools like Kubernetes, OpenShift, stuff like that to really upscale and do load balancing, all that fun stuff that I wish I knew a ton more about, but we'll get there. So. And one of my favorite things here too is there's Docker Hub, and a lot of the times the solution you're trying to build, someone's already built it, and it's as easy as just doing one command, Docker pull, well, OK2, and Docker run, and it's incredible how much is out there on Docker Hub. You can even have set up your own internal Docker repository as an organization, and that's something that we've done here at Intermountain as well. So let me talk about some of the basics of Docker. My background is definitely as a statistician. Uh, and and so I think hopefully this will be helpful to you guys as well. I think of initially taking a step back and saying, okay, before we really dig into the syntax, there's kind of this process that you need to follow. And of course, like many projects nowadays, you're going to create a project folder, and the next step that is pretty much the main step for being able to use Docker is to create your Docker file. And your Docker files kind of have the ingredients and the instructions on how to create that image for your application. And honestly, that's all you really need to get started, is just a Docker file. But to really make it useful for your specific use cases, you're probably going to add app-specific files to the project folder, and add into your Docker file instructions to say, hey, pull these app files into the container so we can run our application. Next step is to build the container. And one of the things that, after spending hours and hours and hours iterating on some images that we were creating, we finally realized, whoa, hey, Docker files are kind of built sequentially, and they do some smart things where they cache, right, as you're going sequentially. So it's really smart to, maybe install your Linux dependencies first, and then your R dependencies, or Python if you're using Python and R. And then at the end, you want to copy your files over for your application. Because it caches, if you just change your code at the very end and rebuild your Docker image with your new code, it's not going to have to rebuild, spend like 20 to 30 minutes rebuilding all of the Linux libraries and all of the R libraries, where if you had inserted or copied over your application code at the start, it's going to rebuild everything every time. And believe me, you don't want to sit and watch your logs at a computer all day. It's no fun. So, and then the last step is to run the container. So, and I do want to ask, if you guys don't mind, in the chat, maybe rating yourself on a scale of 1 to 10. 1 is no Docker experience, 10 is you're a Docker genius. If you don't mind rating, okay, just so I can get a good feel. I know I started into some of the basics, but okay, good. So it seems like a big part of the group is 5 and under, and then we've got some that have more experience. Okay, cool. Thank you guys for sharing that. So I am definitely, my experience with Docker is probably lacking, when compared to some of our DevOps or ML Ops professionals over here. But I know enough to be dangerous, and I've really learned a lot in the past few months, especially with the high priority tasks we've been given and started using Docker with. Okay, so I included some of the links here at the bottom. I will make sure and upload these updated slides and some of the reference documents that I've created to the Salt Lake City R users group GitHub page, so you can enjoy those on your own later. So so let me just show you a really quick Docker file. One of the things that, maybe is a little bit deceiving about comparing it to like a recipe. The beauty about Docker is that you don't have to do everything from scratch, right? Someone else could have built something. So in this example, the we're pulling, I'm guessing a Node.js container or image that's already been set up, right? The next step is we're setting our working directory. We're going to copy over our package build files, and we're going to go ahead and install it with this run command. And then we're going to expose port 8080 and document that. And then this CMD is the part where we're going to say, okay, whenever we run the container, this is the command that we want to run as we start. And then this last part is, let's just copy the rest of the files from our current directory on the server that Docker is installed on to the current directory in the image, right? So, which we've set up here as the user source app in that container. So, and feel free if there's any questions, feel free to use the chat, and we may, you know, Julia or Andrew may jump in and ask that question throughout the presentation, or we'll have questions at the end, depending on how that works. So feel free to ask any questions in the chat. So once we have our Docker file, we're good there, right? The next step is really building it, sharing it, and running it. So, and it doesn't have to be in that order, right? So, I really love, this is one of my favorite things about Docker, that there isn't a steep learning curve, because, you know, the commands on the left-hand side of the screen are like 90% of what I use all the time, right? So Docker build, the -T there in that first example is basically giving your image a name and then a tag. So name comes first, and then you do :tag, and then you can barely see it, but there's a little dot here that says build the Docker file that's in the current working directory. And I'll show you an example of that. So you can also list all of the images that are built locally on your Docker server or laptop, right? And then of course you can remove those images. Once you've built those images, you can share them by pushing them, you know, whether that's up to Docker Hub repository, or an internal Docker repository. You can do that. You know, a lot of times Docker pull, Docker pull is similar to this from here, where from is going to pull this image that's stored on Docker Hub or wherever it's located or hosted. And then Docker pull is basically the same thing, but sometimes you can even just use Docker pull and run an image that's been shared just as it is, which is great. An example of this is we actually had some need for a Selenium server, and you know we'd set it up for individual users, but we wanted a server that everyone at our organization could kind of hit as the Selenium server. And you know, it was a little bit difficult at first trying to set that up myself on Linux, but then I found the container that was, or the image that was already built on Docker Hub, and I just did Docker pull, Docker run, and it's still up and running today and in use for our web scraping delight. So it made that like super easy. I mean, literally I spent hours trying to set up myself and failed, and literally was seconds before I had it up and running within a Docker container. So awesome. I love it. So and then the last piece here, I'm pretty sure on these you don't necessarily need to put container here on some of these commands, but you can do Docker run, give your job a name, and then This dash P will also talk a little bit about too, for typical web servers, right? Maybe it's a web server. Port 80 is your HTTP port that serves your HTML content, right? And so you can imagine that if you've got a bunch of these little tiny web servers on your Docker server, you can't run all of them on port 80. So what we do here is we actually map port 80 inside the container to port 5000 outside the container. And so now we can have multiple web applications that aren't going to be bumping into each other and having some conflicts. And we'll talk about that too. So, and a lot of the same commands as the build, right? Or Docker image, right? You can list the images that you have. You can list the containers that you have running. You can remove some of the containers that have been deployed, right? Or you can stop them. You can start them. Anyway, this again, this is a cheat sheet from docker.com that's available, and the link, I think if you even click on this, when you open up the PowerPoint, it'll take you to that webpage. Okay.
Before you start on the demo, there's a question about, so you pull these Docker images, some of them that have been like made by other people and whatnot, and a question about like some of them being big, and how like, have you run into problems with I mean, you install packages into them, and sometimes they balloon to very large sizes. Has that been a problem, or are you going to talk about this later, or how have you dealt with that? Or I think it is Paolo who put this in here, said he's maybe started looking at like Docker images that are built on like different Linux installations to try to deal with that. Have you dealt with that, or is your like we just use the big images?
Well, so far we only have like a few images all on one machine, so it hasn't been as big of a problem. But I know the true principle of Docker is really to slim it down to only what's necessary, right? And for me, when I pull those and install more, it can balloon pretty quickly. Especially the example of our container that kind of has our internal
like
package.
An internal package. Yeah.
Like, you need to set up dev tools, and that's really big, and then you install it using dev tools, and it can get big pretty quickly.
I mean, I saw you had like XGBoost maybe in an example, and yeah, I could see that getting big.
Yes. So
yeah,
I right now I'm a statistician playing with Docker, so I'm definitely not a Docker purist, where I really should slim those down someday.
It's a trade-off, I'm sure, where you're like,
yes,
is it worth it? Is it worth, I was wondering, so a question was asked, like, have you started to work with that, or what have you decided to do about that so far?
Right. So probably where I've run into it most is more when I pull an image that has been built that way, and I want to build a little bit more on top of it. Sometimes it can be so frustrating that, like all I want to do is add the Plotly package to Plumber. And I went through this actually last night. I was up a little bit late because I want to show you a Plumber with Plotly, but I couldn't get it working because a lot of the base images that I was trying to pull from were missing just one thing that I needed to do. And here at Intermountain, and maybe some of you at other large organizations, the proxy is the bane of my existence. And setting up proxy settings with every single open source project sometimes is a pain, and it's just not always set up perfectly well. And anyway, so that's why I gave up and switched to ggplot instead of sharing the Plotly example today. But that's where I've run into it the most. I think that you know, if you can build the container that really, if you know that it's everything you need, I think at that point you can probably say, okay, let's really work on slimming this down. But if you think it's kind of a base image that other people are going to build on top of, you know, maybe you want to keep a little bit of foresight and like, okay, I want to remove some of these things, but I probably should leave it so that if someone else is going to build it, something else on top of it, I don't know, I feel like that would save me as a user a little bit of frustration down the road. Be like, hey, I can't even use your image and I can't figure out how to build on top of it. So I hope that helps. I hope that answers.
Yeah, we'll come back to some of these other questions maybe after we see some of your demo.
Cool. So it was kind of funny. I did a really, you know, Docker ships kind of with their tutorials, and they've got a Hello World image that you can download and just run to see if you got everything working and configured correctly. And I thought, oh man, I'll pull it up, pull that Docker file up, show them what it is, and thinking it was going to be simple. That one was way too complex for me to walk through and explain. So I made my own simplified example of a Hello World container. So let me pull that up. So first off, you can see in this folder, this Hello World folder, all I have is a Docker file, right? And if we look at what's in this Docker file, it's pretty basic, right? So I want to pull the CentOS 7 image, and the reason I'm doing this is because you know, as an organization, many organizations opt to use Red Hat Enterprise Linux, right? And CentOS, pretty much the same thing. So a lot of the commands are going to be the same. If I configure, I can configure my in-house package very similarly the way I do on our Red Hat machines, and don't have much problem. So I'm pulling from CentOS 7 as my base, and then really when I run this Docker image or container, all I want to do is echo hello world to the standard out, and we're good to go, right? So let me close that. And so one of the first things I do after I have built my Docker file, I'm going to do Docker build. I'm going to give it a tag, hello world. And I'm going to tag the image hello world mine, because I don't want to confuse it with the one that's coming from Docker itself, right? So you can be flexible with these tags. They can be text, they can be, you know, version numbers. Maybe you want to do 1.3, right? I'm just going to leave it mine. And then I need to tell the directory where the Docker file is contained. I'm in that directory right now, so I just want it to the current directory. You know, I built this yesterday, so that was super fast. It doesn't take too long for this one. It may take a little bit of time to pull this if you don't have it on your machine already and download it from Docker Hub, but we've got it up and running. It says it's successfully built. Let's go ahead and run it. Docker run, and oh, I'm not gonna add any options here. I'm just gonna go hello world mine. So just like we expect, I run it, it prints hello world, and it shuts down. That's something else. If you are haven't used a Docker a ton, um, uh, once it's done running and shuts down, like that image is gone. Anything you saved in it is gone, right? And there are ways to save what you run in an image outside of it. So, and some of the things you can look here. Let's look at some of the images that we have on this machine. You know, we've got Hello World. I've also got another example that we're looking at. It downloaded, and now I have the Centos 7 on my machine. And yeah, you can see some of the size of these are getting pretty big. I've got some other examples of some of our internal work that we're doing, and some of the Docker Compose stuff that we're working on as well to try and get containers to play nice with each other. So
there was maybe a relevant question to this. There's a question like, how, as a team, do you how do you organize your Docker images? Do you like as far as like directories and or like how do you share them? And do you use them with Git or do you use them with Docker Hub?
Both.
Okay.
So we use Git really to track our projects, and so right now I'm the main user, and I'm really helping our data science team to start using Docker. But essentially, you know, as we set up a project, what we're going to do is we're going to set up just a typical folder structure, right? So we've got our scripts file, we've got our input data folder, scripts folder, input data folder, output data folder, and then a Docker file, right? And then other supporting files for that Docker file in our kind of main structure. We'll push that up to Git, right? And the nice thing about using that is that we can, once it's in Git and we push it up to our repository, we're using Bitbucket. So then once it pushes there, we can now start set up some CI/CD processes to pick up that Git repository, you know, start building and testing that project. And then the end of that kind of build is to push our image up to an internal Docker repository.
Okay. Yeah.
So
nice.
So we kind of use both Git repositories, Docker repositories in that workflow. That helps.
Nice. Yeah. Thanks.
Okay. Awesome. Okay, so let's jump back here. And okay, so now that we built a pretty basic image, I want to introduce you guys to Rocker, which is of course R and Docker. It's an incredible project that you know, a lot of these R solutions have already been built, right? If you want to, you know, spin up a Shiny server in dev or test or our studio server, you know, Rocker has made it pretty easy. And granted, you know, I honestly, our studio has also made it super easy to just install these as well. Some of them, the easiest software I've had to install on Linux, but you know, Rocker makes it super easy as well. Tensorflow is one I listed here because I've had a coworker mention to me, this one is kind of important on Linux. We've got at Intermountain, we have like I don't know how many IT teams. There are a ton of IT teams because we're such a big organization, and they are all amazing on top of their work. And sometimes that can have a downside, especially if you're using TensorFlow, where you know you set it up to match your kernel, in Linux, and then IT overnight decides that they want to keep your machine up to date, and they update the kernel, and suddenly TensorFlow doesn't work. I don't know. This is another question I want to ask. Has anybody had experience installing and configuring TensorFlow? It's getting better. If you have, oh yes, okay. You could say yes. Oh man, it's getting better, but oh man, I remember when I first went through it like 3 years ago. Like you go through step 1, and it's like install and configure CUDA, right? And it gives you a link, and then you click on that link, and then you're sent to like 25 pages of how to install and configure CUDA. It's just like, oh. Anyway, this is a great use case for Docker. I love it, and you know, Rocker has done the work to tie it into R as well. And the best part about Docker images as well is once you've built it and you've got it running, it kind of stays frozen, right? IT can do all they want. They can update the Docker server's kernel all they want, and update Docker, and it's not going to break your environment. And that's why one of my coworkers here at Intermountain is like, I love it because I can set up my TensorFlow environment and know it's not going to be broken. So, you know, RStudio also creates and distributes Docker images, and I put a link to their repositories here. So, okay. So, and I wanted to show you an example here. I think we're going to use one of the RStudio base images for this next example. And Plumber, is everyone familiar with Plumber? Can you put a yes if so, a no if not?
It's probably worth at least a brief explanation
okay.
of what Plumber is.
Okay, cool. So just to give you a brief, and maybe I'm gonna pull up. Oh man, I don't want to give the answer away already. Right? Oh, good, it's not on the main screen. So, okay, I'll pull this over here. So, I'll just pull up the Plumber doc. So basically, what Plumber allows you to do is you can take your R source data code, and with just using some special comments, you can create APIs, web APIs. And the reason I really love Plumber and Docker together is they have some hosting options here, and they've made it really easy to deploy your Plumber API into and actually have it hosted by Docker. And so there are definitely other ways to host it, right? Of course, RStudio Connect, DigitalOcean. I have at one point in time, where is it? I think it's the bottom of the list now. Set up PM2. Yeah, here it is. PM2 is a way to host your Plumber APIs. But I really like that they've made this pretty straightforward to host your Plumber apps. And so I want to walk through an example here. So let's go. Here we go. Plumber, and clear the screen. So when we look at what's in this folder, there's a little bit more than our simple example, right? We've got our Docker file, and I'll pull that up. Docker file. few more steps here. As you can see, I'm using the RStudio plumber image. And then basically on top of that, all I have to do is install the packages that I need. And you can do it this way. They give this example in their documentation on plumber webpage. But I like to use this install packages Rscript so I can set up a few other settings. Let me show that to you. So basically, you know, here at Intermountain, we work with IT to whitelist this specific CRAN repository. So we always want to make sure we're pointing to that one. Otherwise, we may not get it to work. You can set up some proxy specific settings, right? And say,
this actually addresses a question that was up a bit further, was about how you handle things like environment variables that may differ from like your own local development, and then you push up with, so you use that, you handle that within files like this.
Yeah, and there's tons of different ways to set environment variables in a Docker container and building, and yeah, there's lots of ways you can set up. This is how I've done it. I know you can set up like your R environ file or your R profile file to be included in this container if you want to as well. But yeah, I mean, some of the other things you can do here is install specific versions using the remotes package, and but here I really just want to install ggplot, and I'll list some of these other packages that I may need. So let's see, and let's switch back to the Docker file. So then, of course, we need to copy over our plumber app, right? We're going to expose port 8000 because the base image here is going to host our plumber app on port 8000. And then the last step here is just the script that we want it to run. So we just want it to run our app plumber. So let me just show you that plumber.r. Okay, so this is pretty basic application. We're just going to use the diamonds data set, sample 1,000 rows, and then plot that. And some of the decoration parts in here, you want to say, well, we want it to be available to get. Here's the endpoint, how we reference the endpoint, and then here's how we're just telling it the output's going to be a PNG. And then one of the things that I always make this mistake, but you have to add print, otherwise it's not going to work. But yeah, it's pretty straightforward. And this one I've already built. It took a little bit of time, so I didn't want to build it while we were on the call. So, oh, and man, time has flown. So essentially what we get here is now I can go to LPV, my server name, phdev04, and we did 8005. Do I still have it up and running? Oh, yep, it's up and running. I just need to tell it graph. So now you can kind of host your own APIs. So I should take a break here. Time has flown by. And how do you want to go forward, Julia? I am happy to share some of the other slides, basically just screenshots of examples of how we've used it at Intermountain.
Yeah. Let's
benefits, so.
Yeah, so since we are at time, how about if I'm gonna share with you one other question, and then and then we of course understand if people have to head off, and then we'll have you maybe quickly go through a few things that way you've used it in real life. So that was really cool. And maybe if you would like to address this now, or as you kind of go through your real life examples at Intermountain, there's a question about getting people on board with using Docker, especially like a big data science team, like you have a lot of data scientists. How do you get people to learn how to use it? How do you get people to start understanding that it's useful? So maybe if you want to talk about that now briefly, or as you're talking about your real world examples,
Yeah,
that'd
no,
be great.
okay. Yeah, I can talk about that now. I think to some extent has to come from top down a little bit, like, hey, this is what we're going to do, and this is why we're going to do it. But what I've really been working on, I really want to make it easy for our data scientists especially to use, and there are so many tools and solutions that have been built to automate a lot of that, right? And you know, if you have the budget, I would recommend really investigating some of those tools. You know, I feel like RStudio Pro does some of that already. I feel like you know, Databricks does a lot of that already. A lot of cloud-based solutions make it so that kind of Docker and Kubernetes and all that fun stuff is really behind the scenes, so that your data scientists don't really have to learn Docker. But if you want to build it yourself, then I'd recommend, you know, it's not a steep learning curve, but at the same time, you can build ways to automate the creation and all of Docker files and all that kind of stuff. So I hope that helps. So
Nice. So I will say we're at the hour. Thank you so much for everyone who's here who needs to head off. Mark, if we want to take just a little bit more time, because I know people would be very interested if they're able to stay to hear about how you do use Docker at Intermountain.
Yeah, for sure. And thank you if you have to jump off. It was a pleasure, and I apologize for rambling too much. It's a really fun topic, but you're welcome to hang out for a little bit. So just to show you maybe the way we've kind of designed, we're definitely partnering with our data analytics platform team to really kind of build this environment. And this is part of the goal. And when we put this together, we didn't realize how well and how nicely Docker really fit into this strategy. Like on the top, we've got these ability to spin up microservices in any environment, and just you know, as a data scientist, you just play around with it, right? And that's really valuable, because you don't want to waste a lot of time trying to configure and install a lot of these tools if you're just going to play with it, see what it can do. And then on the bottom, you know, the really valuable piece is, you know, pushing from dev or test to prod should be like, should be so seamless and easy that Docker really provided a way to do that, and making it so that our data engineers didn't have to do a ton of Linux or R administration, especially if they didn't understand it completely. So as far as a motivating example, you know, we if you use Oracle, we have a conundrum here, and with governance at Intermountain, not everybody has access to all data, and that's part of the HIPAA requirements, you know, the minimum necessary requirements that we have to follow as a healthcare organization. And so, you know, I can make up some table name that doesn't exist on the top, and it tells me table doesn't exist, right? Or I could actually put in a real table that I don't have access to, and it gives me the same error. And so it works. It's okay to figure out what I need, what role I need to be able to run that query, but sometimes you have a really, really, really long query and you're new, and you know, you want to set up something a little bit more automatic, but you always have to enter your credentials in to access the metadata, right? And so this is where Plumber and Docker was perfect. I was able to get some app credentials that had access to the metadata, and basically what an individual now can do is, well, here's my API. All they have to do is connect to this API, give it a string of the query they want to run, their user ID, and it will go through the metadata from Oracle, check what access you have, what access you need, and then let you know out of all the tables in your query, which ones do you still need access to, and then what roles do those tables tie to, so that you can quickly get the access you need. Because there's a request process. Anyway, when I was an employee, I inherited a query that was over 2,000 lines of code, and I spent like a month trying to get access to run it. So I said, I never, ever, ever want to do that again. So the beauty about building an API is you can put it with Docker. It's hosted. You can put it in your package, right, as a function. So I just say, hey, get the roles for this query. Select star from train XYZ patient, and it tells me, okay, here's the 2 roles that I found that table's contained in. Here's how many people have access to those tables, and do you have access to the table? And it says yes on everything, because I do have access. And then, do you have access to the role? Yes, I have the first role, but not the second one. So I don't need to do anything else on this one. I've got access. I don't need a quest anymore. But I can also create a user-friendly application using Shiny, and use that same API. Everything's exactly the same here, except it's a little bit different interface, and the same output. You can even say, hey, you can input a SQL file here at the bottom and submit, and it will run and get what you need. It's been super helpful, and I definitely get some of our coworkers here at Intermountain. They're like, hey, Mark, can you tell me where that tool is, that Shiny app that you built? We had someone start on new, and it really makes figuring out what access you need easy. So that was one of the use case examples that we had here at Intermountain for using Docker and Plumber. So yeah, this is just a review, and because of COVID, we can't really watch football. So Docker is going to be our field goal kicker, and go for the win. So this is just a review, I think, of all the points that we talked about previously. So next steps for us are really automating that process for data scientists, so that, honestly, to them, they don't know they're using Docker, but they really are. And or at least setting up the environment for them, so that it's a lot easier to tweak something that's already set up for them than to build it all yourself. So and then also kind of exploring Kubernetes, using Docker Compose, other things like that. So that's everything I had. Thank you.
Awesome. Thank you so much, Mark. That was really interesting. And it is really interesting to hear about like how these tools are being used in real life organizations, especially ones that, you know, like here locally and like where you and I live have
Uh-huh.
impact so much, you know, like so many of our real lives. So that's really cool. I know we are past time. So if any, like, I think we'll maybe just take like one or two. If anybody does have a question that they want to ask, you can use the raise hand feature and we can unmute you if you want to ask something. But we do, I know we're past time. So we're just going to, for everybody's time, we want to keep this brief. But if somebody does have something, you can click that raise hand feature. All right. Have I successfully unmuted you?
Oh, yes. Thank you.
Awesome.
Yeah, thank you, Mark. This is May Todaka. I was just wondering if you used to use pack rats, and if you're, I guess with the Docker transition, you're probably not using pack rats anymore.
Yeah. Did you ever use any other like version, like package versioning?
Yeah, I've been
Packrat,
using pack rats.
RN. Did you ever use anything like that before?
Yeah, that's a great question, and good to hear from you, May. I think we met a couple times, but yeah, I am kind of an old school art programmer in that, you know, I learned R like over 10 years ago, so I've definitely stuck to install packages for a lot of things, but we've got an intern that's really selling me on Pac-Man, right?
Pack rats, yeah.
There's Pac-Man, which is different than Pack-Rat.
Oh, really? Okay.
They're all sort of attempts at this issue of like package versioning. So they all are like different sort of ways at getting at this question. So anyway, keep going, Mark.
Okay.
Yeah, one of the ways I've noticed, so with a lot of our COVID work, we're iterating really quickly and you know, rebuilding some of these images several times a week, and I've noticed, especially since we're using Red Hat Enterprise Linux or CentOS, I should say CentOS, that that they've broken a couple times because of updated versions of our packages. And so the way that I've gotten around that is to use, I think it's the remote, or you can use DevTools package to install a specific version. And so that's how I've gotten around the issue that we've had there. So I've used the DevTools and remote packages. So
yeah. So one thing is that like Pack-Rat or Pac-Man or something like that will get you the package version, but they will not solve your issues around TensorFlow or like the spatial, like all the stuff that gets you have to install to get those things to work. If any of you here are like working on Linux systems, I know I work for our studio, so it's like a little bit like, you know, advertisement or whatever, but this part is free. If you're not using the RStudio package manager, you should really look into it. You will have to get it whitelisted, like if you are working with IT folks, but it's installing binaries for Linux. So like instead of sitting there and watching the code compile for a zillion years, it's binaries for Linux, and it's fast and works so well. It's super cool. And so for example, it makes building the Docker container really fast, which is really nice.
I'm definitely going to look that up now.
You should look into it. Yeah, you should look into it. So it's the RStudio package manager. It will have to be like whitelisted on your, if you have a lot of firewalls. Okay, we are past time, and so I'm gonna wrap this up. I want to thank you all so much for coming. I want to thank Mark so much for his investment in this talk, which is super practical, super impactful for so many of us working in the real world and getting this you know, like getting our working as data professionals in organizations. You can, you know, find us on Meetup. We will have this. This talk was recorded. We will plan to post it on YouTube if anybody you want to share it with. We will be meeting next month in September, talking about modeling and machine learning defaults and about natural language processing. So we will look forward to seeing you there. So thank you all so much for coming. We're going to end the meeting now.
Thank you.
Thank you all so much.